Can we go after?
Actually, the team Alejandra, Brian, and Fernanda. Maybe we are going to wait for Fernanda because she informed me that she's having meeting, so she joined later. So she want basically me to move their presentation when she's available. So if by the time they finish, she come back, then we can continue with them. If not, we go with the team 3, then be back to team 2.
Yes, sure. She already told us if we can wait for her.
Yeah. We will wait. Yeah.
Okay.
So yeah,
And
go ahead.
then
You can share your screen.
Where is the order of these presentations established? I did not quite get that.
in the first
In
sheet,
the-
deep
in the-
dive,
Uh-huh.
deep dive
Oh,
groups.
deep dive groups. Okay, cool.
Yeah.
Gotcha.
So-
Thanks.
So yeah, we can go with Paul Mejia, Gautier, and Juan Antonio. We can hear their talk first, then we continue. There isn't any order. I mean, basically, it's just.
Wait up, please.
Okay.
Let me just. Can you see my screen now?
Yes, we can see.
Okay, just hold on. Let me check something. Oh, again.
Yeah, it's all good now.
Yeah, sorry for the tech problem. Okay. Our presentation, well, our topic is mining cryptocurrencies, which is a really hot topic at this moment, especially for the money. We are team 1, and we are composed of Gautier, Paul, and myself. So it's mining cryptocurrencies, decentralized overview. We have 3 parts on this presentation. The first one is to actually speak about which is behind mining cryptocurrencies, which is blockchain technology, what's behind cryptos. Actually, the crypto mining, which is picking up virtual coins. And number 3, which is Bitcoin and other game stocks. Well, as I said previously, we first are going to speak about what is a blockchain. Blockchain is a database that stores data or records in a computer or computers electronically. Means that actually this records all the transactions in a computer network. Each transaction is added in a space called block, and actually it links with subsequent ones. And that is why it's called a blockchain, because it forms a chain of blocks. Sorry, sometimes I get a little bit nervous. There is several parts that actually a blockchain is composed. The first one, and well, basically the most important, is the blocks, which they have all the information. A block refers to a chain of different blocks that contains records. We must take in consideration that the first block in a blockchain is called Genesis. And it's a really important thing that we must say, since Genesis is like the basis of the whole blockchain. Without the Genesis, it won't be possible to actually continue the blockchain, because all the information gathered in each block has also a hash that is shared with the rest of it. So a different hash from another block will be compatible with the genesis at the beginning, and chain it won't be possible to form. The second one is a ledger. Basically, it's a system that keeps all the information of all the participants in the blockchain, their currency balances, and actually do all the records of genuine transactions. And it's also auditable, and it's validated by the whole nodes, because since this is a distributed, it works like a distributed system. All the nodes work in consensus to validate transactions and that kind of stuff. We will see that later on. Distribution means that all the parts hold copies of the ledger. A blockchain is not, could be centralized or decentralized, but actually just refer on how, it just refers to a matter of design. In the transaction, the decision to add a transaction to the chain is made by consensus, is what I spoke about earlier. All the nodes gather, as we saw in distributed systems, and they form a consensus in order to approve a value, or the value of a node in this case. And confirmation. A confirmed transaction means that it's been included in the block and also included in the blockchain. All the transactions have been officially recorded, and it's not possible to take it back. And this is the blockchain components in a really open wide view. Next, we are going to speak about how a blockchain works and how it's possible to get it secure. The first thing is that we receive a transaction request. Could be real estate, could be contracts, could be banking or cryptocurrencies. But all of it starts with a transaction request. Later on comes a distribution. The transaction is broadcasted in the peer-to-peer network through all the nodes. And this also being done across the globe as well. After that comes the validation. All the nodes in the network, as we said previously, validate this transaction using algorithms and solving very complex equations. And when they find the transaction that's actually legal, records everything inside the blocks. And after this, they need to add a block in the chain. And this new block is added to the previous one, and they share a hash that makes them like provide some kind of security to each node. And we're going to speak about security in the blockchain. Well, first of all, it's immutable. No one can manipulate data entering the blockchain. The nodes inside of it, it's not possible to do reverse engineer to them. So if there is some kinds of error, if there is a chance of there could be a mistake or something inside the node, another one is added to the chain, but the previous record of the one that is wrong, it maintains as well, which provides security to the blockchain. Okay, now Another way to secure the blockchain is about it has a chronological structure, has a linear order. This means that if an attacker wants to, make illegal stuff to it, it has to start from the last one and then move on to the previous one and so on, which start to make everything very difficult. And also the proof of work. Proof of work means that it's a complex mechanism that makes it really, really, really hard to hack it. This means that the cost of hack a blockchain could be really, it's not business, If the attacker wants to do it, it has to do it to the whole chain, and time, intellectual work, energy invested is just not it's not worth it, and also provides time to the other users to verify if the node has been compromised. And there is proof of stake as well. This means that each person that actually have mined before in order to obtain blockchains, it gains, it's like money power, they have a lot of cryptos, so they can they have preference to validate new nodes, which make it more secure. Kauter, how long do how much time do I already invested? No, like 5 and 8 minutes. Well, I will continue really fast. Now we have the types of blockchain. The first one is public. It's open to everyone. Everyone can make changes, and all the nodes validate all the transactions. No one controls it. It's decentralized. The private ones, an organization or a government control this blockchain, impose all the rules, and decides who can add nodes and who cannot add nodes. A consortium, it could be a blockchain that it's owned by several companies or several entities, and it's like they own it, but they also apply rules as they were a public chain. So they can control it, but it's also more flexible with the rules and can be more open. And the hybrid that actually combines public and private features of blockchains. These ones are really, really good for real estate or retail in industries. And I will think. Now the next topic is crypto mining.
Yeah. Well, Juan just explained a little bit what is behind the cryptos and everything. And blockchain is the technology that makes this possible. Blockchain requires the block, the ledger, the distribution, the transaction, and the confirmation. But this needs to be a business for companies and for the world. So in mining, we can have the proof of work scheme or proof of stake. After you, miners are like validators of the transactions. When you perform a transaction, let's say you need to send 1 Bitcoin to another person. What is more attractive to the people is the security of the network, and there's the miners need to validate through the nodes that, like, for example, In the practice, I have moved cryptos, and I receive an email where it says that there's a request of transaction, but needs to be validated 30 times, and I need to wait a little bit, minutes, for this transaction to be validated. And after the miners validate this transaction, you can have your coins or whatever you moved. But there needs to be a reward for the miners, because it takes to have hardware stuff, and another one is the power. There are highly power consumers, and the reward is you can earn coins by mining blocks, and it's like lottery. You can, well, it's not lottery. The fastest miner that resolves the transaction will get the reward. Can you go to the next slide, please? There are for proof of work scheme, which is the one that uses right now Bitcoin and yesterday Ethereum, because today change it to proof of stake. There are like ASICs, the application specific integrated circuits. These devices are has the name says for specific application. There are ASICs for Bitcoin, there are ASICs for Ethereum, there are ASICs for specific type of algorithm that they need to resolve, but those are not affordable for the common people, because they cost from thousands of dollars to too much money, and they are not affordable for the people, because they consume a lot of energy and the profits are not that high. These are created for big companies that I don't know, they have government contracts to get cheap energy, but because the other way is not worth it. And for the people, the normal people, let's say, we have the GPUs. GPUs are very used. The gamers cards, they are used to build mining rigs. And there are a lot of graphic cards there at the market, the ones that are more powerful than the others, but at the end, they are like teamed to create a rig. And could you please go to the next, please? The next slide. And at the left, we have what it looks like a real Chinese crypto mining. As you can see, if there are hundreds of ASICs, so the investment is huge, and they are like this is a whole industry for them. And this is not Photoshop or something. There are tons of these kind of facilities to mine Bitcoins. And in the right, we have a more household mining rig that everyone can build. For example, it has 6 cards attached to a motherboard, and with an algorithm installed, they can start mining cryptos right away. If you have any question about the pictures or something, you can ask. Okay, the next, please. Well, but how this what this needs to be regarding the cloud computing, right? When if you have one rig, let's say, your mining power is insignificant against the network or big competitors in the crypto mining game. So there are pools that some companies are to offer services like serverless or infrastructure, like serverless infrastructure to join little power of crypto mining, and people like me, for example, I can join a pool and I can offer my power to the net, and in a pool we can share all the people's power mining power mining, and we can compete against the big ones. So, but the difference is that we are like getting the rewards are equally split by the users, and the mining pool gets a fee, usually 1 or 2% of the blocks mined. It's like a combination of one. I have in my I don't know in my living room my mining rig, and I have a server full scheme, and in for the pool they're like serverless. I just need to install a software that manages the functions that I need to use, and they provide all the infrastructure from their side. Some disadvantages are that you don't have autonomy. You are like under the mining pool policies. Can you go to the next one, please?
Paul,
Yeah.
which GPU models do you have?
How do you know you have? Well, I have two rigs. I am using RTX 3000 series cards.
Okay, how many money you can obtain with that configuration?
Well, 1 year ago, you were like mining, because if you are like doing this to like get some coins, and then you can sell them, it's like a instant business. But I am more like a holder, so I mine, but I have like my reserves there holding for the future. But I don't know. It's hard to say, because let's put some percentages. If I was like mining, I don't know, let's say a number. It's irreal, but 10 Ethereums last year. Yesterday, because yesterday I was mining like half of Ethereum. Yeah, it fluctuates a lot because with the world crisis, it also impacts this kind of business. And that answered your question.
Yeah, thank you.
Okay. For mining, there should be the three main components: the mining rig, which are the computer, the big computer that you have. Usually you use NVIDIA cards or AMD cards. Both behaves almost the same. The more cards you get, the better. The management software could be HiveOS or Windows. Windows, you know the pros and cons, but HiveOS is simplest. It's Linux based, and you can. It's also there's an app for the cell phone where you can manage. I don't know, fan speeds or power of the CPU. If there are like, I don't know, for example, where in home there's we are right now at 34 Celsius in the middle day, so you can slow down the power, and in the night where it's a little bit fresher, you can increase the power, and you can modify in real time the settings of the cards. And the wallet, you can have cold wallet. It's called like a USB key, and you can have your cryptos stored like in a USB memory, and you can have them in your own hands, your own keys, and you can have them in the web. But I'm pretty sure that you have read that there are some webs. Sometimes the webs are hacked, or the owner run away. But it's there are. For example, for the Mexican market, we have Bitso. It's regulated by the government. This is a trusted like trading house where you can store your cryptos if you want, or you can trade them. But Bitso is the only one that it's for Mexicans. There are others, but are not official. Next one, please. This is like a HiveOS looks like. You have for example, this has 8 GPUs. All of them are AMD cards. The 28.92 are the hashing power. The temps, the fan speed are, for example, in this case, 80%. And what energy are they consuming? And you can tweak them as you wish. You can have different models, and you can mix them, and you can have different configurations for each card. And this is like it's like a very practical tool, because you don't need to it manages and send the hash power to the pool in the network. Next one, please. Well, everyone knows about Bitcoin. Bitcoin is the biggest one, the main actor of this game. But there are another ones. Ethereum is the second right now. Today is an historical day. This is a very special day, because this is the Ethereum just changed that to approximately 2 a.m. from a proof of work scheme to a proof of stake scheme. What this does mean that miners can't mine anymore Ethereum. It was the second more profitable coin to mine, but right now today it dies for miners. The proof of stake are also validators. There are also validators that provide security to the chain. But if you remember, Juan mentioned this aspect, that it is like more centralized, because if to be a validator, you need to have at least 32 Ethereums. There are millions of Mexican pesos. if you want to see more than 3.5 Mexican pesos, more or less, at the current market value. And well, if you are a little bit more curious, the GPUs or the ASICs consumes a lot of power, and some governments were worried about this like environmental impact. So this Ethereum passes to a new way of work. It only takes that if you have more than 32 Ethereums, you can be a validator. But it's like in like the current society, that if you have money, you can take decisions or something like that. But no more for miners. Bitcoin will be for miners, but not the common people. This is for in big industries, as I showed you in the picture of the big farms of ASICs working for Bitcoin. And Bitcoin and Ethereum are examples of this decentralized. Well, Ethereum right now, I'm not sure if this is centralized, but for example, the third one is XRP. This is centralized. it tries to replace the current SWIFT system that are used to international transactions. It's the purpose of this token. And it has a slow growing, but yeah, it's still waiting for its bull run. Okay. Gautier is going to talk about a little bit of a problem.
Thank you, Paul. Thanks a lot, Paul. So my colleagues or partners, they already have told us something about security. Juan Antonio said blockchain is not, well, you can modify it. It's not affordable, as Paul said, or as Paul said in the chat. Also, Paul Mejia, he told us something about the resources you need, the hardware you need in order to create this crypto mining. He told us something about ASICs and GPUs, but well, I do not much about crypto mining, but I have a question since a time ago, and it is the blockchain, this crypto mining is as secure as everyone is saying. I mean, the blockchain is not, you can modify it. Well, I would say yes, the blockchain is pretty secure, but you know, it could be some way to get a revenue with no effort. In this case, I mean, cyber criminals, hackers, whatever you want to say it, maybe they don't take your cryptos, but they take something else. Someone in this forum can say what they take. If they don't take the coins, what they would take. This is a question for you. If you want to answer something, okay. If not, I will continue. No answer? Okay. I would say they don't take the coins, but take your resources. Yes, Jose Antonio, take your CPU to mine, take your resources. They don't wanna spend money in resources as Paul. They don't wanna buy nor ASICs nor GPUs. They wanna get coins or bitcoins or whatever they can be named without paying for resources. So the next, please. Well, in fact, I went into Google Scholar in order to find information about how you can hack the Bitcoin's process. In fact, seems there are no way, but they have this workaround in order to, as been said, take your resources. In fact, this paper in their introductions says that there are some malicious websites. And when you go into test malicious websites, without realize it, they start using your resources in order to process crypto mining. In the beginning, it was done in the browser, but with the time, it was created, or this solution, sure, the render. The render requires a lot of gigabytes of memory. So in the browser, you can do that. So it was not a more affordable way to create Bitcoins without paying for resources. But you know, the people is always wise. So they have a response. And this response nowadays is to have the target to resource, well, to have as a target resources rich and less protected. Which kind of resources are these? In fact, the targets for this are the DevOps platforms, where they have a lot of resources. In fact, the test, name it as continuous integration, and the deploy, name it as continuous delivery applications, they need a lot of resources, and these cyber criminals realize there is not much protection on this stuff. So next, please. So in this case, this paper has the proposal is to create some way to scan, the webs, in order to know if there is some hijacking or CI jacking, where through this proposal, you can realize that these resources, continuous integration, is already taken from someone else in order to get crypto mining. In fact, this proposal takes something that Paul said, that is the wallet, addresses, domains, the pools. They unlocks this CIG scan, gets into these items, and they search for evidence of someone else is taking or using it to create crypto mining. In fact, here we can see the logo of a crypto named Monero, where seems that it was really easy for those guys to get into this crypto and get resources in order to create them. Next one, please. Well, something critical here is that most of these continuous integration platforms need a GitHub as a repository. And in fact, this proposal of scanning goes into GitHub, goes into the CI platforms in order to search for evidence of hijacking. And also here we have in the figure one kind of the structure of this or architecture of this proposal. In fact, we have a crawler, an interpreter, and the mining detector. We have these columns through this proposal is base. Next one, please. And also we have here the components of an attack. In fact, we have the attackers. We have also the code repository, and in the right-hand side, we have the CI platforms. You can see the following flows in order to be processed an attack, and also among the process, trying to say it in an easy way, the attacks get or has to be with GitHub and the CI or the continuous integration platforms. They are attacked, and also the proposal or this scan stuff goes into these resources in order to find evidence of hijacking. The next one, please. Well, in this paper, there are some results, and it says that they need 5 servers, or the demo or the proposal, or in order to get results in a real life example of this proposal. The authors of the papers take 5 servers, and they get into about 600,000 GitHub repositories, and it take about 17 days to finish all the task or all this task. And they found about 900 repositories, about 0.15%, as illicit or repositories with evidence of hijacking. The next one, I guess this is the last one. So after read this paper, I realized that it's not required to take the Bitcoins or modify the blockchain. You just need to get some walk around in order to get some resources as free in order to get some crypto mining. So Paul, maybe you can have this idea so you can save money buying GPUs or maybe ASICs, so you can get a better revenue using these ideas.
by cheating on other people. um, if you're thinking that you can mine with your CPU, there's only one coin that you can mine with a CPU. It's Monero, but it's not worth it for a single user. I think they combine all the robbed resources across the network to make it profitable. But yeah, it is a way to hack on cryptos, but not directly to the net, but for the hardware. Yeah.
I have a question.
Excellent approach.
My question is, you were talking about Ethereum has changed from a stake of work to a stake of proof.
Proof of stake to proof
of work to stake. How this is going to affect the mining?
It killed the mining for at least for Ethereum. Yeah, there's no more mining. I was last night wide open waiting for this to happen, and suddenly there were rejected transactions, and then that was it.
Okay, can you explain what is the proof of work and proof of stake so everyone knows?
Yeah,
talking about?
Yeah. Proof of work is a scheme where for miners you have your GPUs. Let's say that you are a coin user, right? You're a trader. You don't have to do anything with the mining. So you need to, I don't know, to convert Bitcoin to fiat, the real money, or the other way. And you need for that transaction, you need to validate across the network. That transaction will go to the network, and the miners are validating by resolving some complex transactions. And after that, after the miners validated this transaction, they can like check that everything is good, and the transaction gets done, and the miners get a reward. Could be there are blocks. Could be 1 Bitcoin or could be 100 Bitcoins. It's like lucky. It's like a gamble. It's like luck. And now there will be the same, but you are not using GPUs to mine. You're not using power. You are using a server with 32 Ethereum staked already, and you have the power to validate those transactions. So the security will go with the people that have a lot of Ethereum staked.
Okay.
The rich people, let's say, right now, and it passes. Some people say that it passed from a decentralized network to a centralized network. That only a few can manage the security of the network.
Okay. What is going to happen if someone with a proof of stake wants to cheat?
No, because it's the same approach. There are other validators.
But what will happen if someone wants to cheat?
what kind of cheats are you referring to?
Yeah, if you say, yes, I'm validating, but I am not one person that can validate.
No, you need to pass some filters or some. No, I am not able to say I have 32 Ethereums. I can be a validator. I need to provide them to the network, and there are some other checks that validate
okay.
you as a validator.
I think I can help with that question.
Mhm.
The proof of stake, yes, that's correct. It's only a few nodes can validate depending on the level of the money that you put in that, right? You have to have certain amount of Ethereum in this case, for example, and that Ethereum is put in like a safe, how to say,
As a proof. As a proof.
yeah, as a proof that if you make a wrong like transaction, if you want, I'm sorry, I'm struggling here. If you validate something that was not supposed to be valid or fraudulent, that stake is
lost, right?
taken from you. Yes, is lost. So that's why, yeah, it is something that, yes, you are going to be a validator, but if you made something fraudulent, then we're going to take that stake from you as a collateral. So I think that's yeah, that's how that works.
Like a consequence.
Yes. Yep.
Okay, thank you.
No question.
Okay, thank you guys for the presentation and little discussion. I mean, because you took a lot of time to present, so I want to finish it here, so we can have enough time for other three groups to present their research, basically what they did. So thank you. Let's go with the second group. Fernanda is here, so we can go in the same order. Alejandra, Brian, and Fernanda, they're going to talk about Lambda.
But Brian is not here, I think so.
Brian is going to show up late, or he didn't tell me anything about it?
Yes, I think he's driving to his home.
Okay, so let's go with the third group. Okay, we can wait. Let's go with Jose Antonio, Oscar Gallegos, and Ricardo Rey. So they're going to talk about OpenStack.
Sure. Cool. Let me share the screen. Which screen are you seeing?
You're seeing your browser.
Yeah, the overview.
Awesome.
Cool. So we're gonna talk about OpenStack, but give me a second because I have a little intruder here. I need to get rid of him. Give me like 5 seconds.
Yes, invited.
Yeah.
Why that's good.
Hey, sorry about the little guy. He really wants to be a software engineer. Cool. So yeah, we're gonna talk about OpenStack. So OpenStack is essentially like, we can go to the next slide, please. Cool. So yeah, I had to rummage the internet to figure out what the hell OpenStack is, because it's not like super straightforward. So OpenStack is essentially, it's not like one thing. It's a bunch of open source projects that allow you to handle some infra as a cloud, right? So basically, you have a bunch of servers lying around, you install these components in all of them, and suddenly you have a cloud. It can be, you can like host your own private cloud, you can like sell it, you can do whatever you want. You have a cloud, right? This cloud is compliant with NIST's definition. I honestly don't remember all the details, but it's like self-service and all those things that the NIST definition kind of like requires. So essentially, it's not a single thing that you install. At first, when I was researching this, I was like, okay, how do I install OpenStack? And there's literally a video from an OpenStack kind of like convention that says OpenStack is not a thing. Like you don't put OpenStack in your services. Like OpenStack is a bunch of things. So yeah, the idea is it allows. So the example that I found online is in a typical company. Maybe you go like you write a bunch of requirements, maybe in some predefined format, or maybe just send an email to a friend and tell him like, hey, I will need like these 3 servers with so much memory, blah, blah, blah. So it gets to some people in some DevOps team or some like infra team or whatever. These people go through your document and it's like, oh, Ricardo needs like these 3 servers, blah, blah. Let's spin up some virtual machines that match this criteria, right? So they do that and eventually they go back to you. And it's like, hey, here's your stuff. So if I'm just asking for like 3 machines, that's probably not gonna be super error prone. But if I'm asking for like dozens of machines and database instances and networking and blah, 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 things are probably gonna be bound to fail, right? Because there's a lot of human intervention. So as we probably all know by now, with things like AWS, you have code to describe your infrastructure, right? Like you have, for instance, CloudFormation, where you describe all of your services. So you just give this code to AWS, and through APIs, AWS magically brings all of this infrastructure to life. So there's no human intervention. And with OpenStack, you can get precisely that. Like OpenStack exposes some APIs, and with some well-defined APIs and format, you can request your own resources and have a computer program do that for you. And there's absolutely no human intervention. So it's a pretty cool thing. So we could go to the next slide, please. Cool. So I think this is Oscar or Lasse.
Yeah, it's mine. So what's the relevance of OpenStack? Because previous to this presentation, I haven't even heard about OpenStack. So right now, OpenStack accounts for about 25 million CPU cores in production, so it's pretty huge. And the OIF claims that from the last year to this year, it has increased like 50 million. So it's pretty huge, the progress that's being done from 1 year. And also it says that there are lots of new clouds added, and well, the biggest telecom from China, which is China Mobile, is investing in it, and it has just go through 6 million cores to power its 5G mobile network. So it's pretty huge, this OpenStack. And it's because what Ricardo said, like, right? You can have all your stack, all of these services from OpenStack within your private cloud, and you will instead of using like AWS or other product like OCI or Azure, you will need to with OpenStack, you need to have like people in charge of all these new services, because you need to have like all the infrastructure to install all these new services and OpenStack, right? All the stack from the cloud.
Cool. So this is a high-level overview of all the things that kind of comprise OpenStack. So yeah, as I was saying, OpenStack is not a single thing. It's essentially a bunch of open source projects, and they all work together. So for instance, just like focusing on the center part, there's a web front end called Horizon. So it's similar to your AWS console, right? Like like ClickUps, like you click on stuff and your resources magically come to life. You can also do API, but it's very convenient to have a front end. So that's Horizon. Then you have Nova for compute, which is akin to EC2. You have things like Swift for object storage, which is similar to S3, or Cinder for block storage, which I honestly don't know if S3 if AWS has something similar, but I'm pretty sure they do. You have something to manage images for containers, right? Like you have this server Glance at the bottom in the last blue one. And you have the identity provider Keystone, right? Like Keystone is, I'm guessing it's kind of like a Keycloak implementation. Like it is responsible for authenticating users and spitting out access tokens so that users can make API calls. So that's like the core. And you can see there are a lot of things there. Not all of them are actually like completely necessary. Some of there are a few core ones, so we are going to talk about them, and then there is a whole set of tooling around it, which I honestly did not go into because there's quite a few things to talk just about the core OpenStack itself. But then there's networking with Neutron, which is kind of like similar to Amazon's VPCs, I guess. So there's a lot of like analogs that can be made with AWS, but essentially it allows you to transform your own infra, your own bunch of servers into your own little AWS with its own APIs. So yeah, let's go to the next one. Cool. So how does this work? So in order for you to say that you have OpenStack, quote unquote, in your computer or in your servers, you need 2 services, 6 core services. So first you need compute, which is Nova. It basically knows how to spin up virtual machines, and it can actually spin up like bare metal stuff. I didn't fully read into that, but it has that capability. So it's like EC2, right? Like you get compute instances. That's about as simple as it gets. You have Cinder for block storage. So block storage is for volumes, right? Like for file systems, for all that stuff. So you get that with Cinder. Then networking is very important, right? Like you need all of your computers, all of your servers to be able to speak with each other to like actually show a cohesive view to the users. And also like if I create 10 machines, I probably need them to speak with each other, right? Like maybe it's a microservice architecture and I have containers in different machines. So I really need them to be able to find each other and see each other. So Neutron takes care of networking. Glance is the image service. This is just for containers. Swift is for object storage, which is kind of like S3. Like you can just store like complete files and complete images and whatever you want in there. And then Keystone is kind of like very important. It's the identity service. So if I wanted, like if just some random user wanted to create some resources in this like cloud that I am hosting, they wouldn't be able to unless they are able to authenticate. So that's what Keystone does. So those are the core 6. Like you need to install those 6 in each one of your servers in order to claim that you have OpenStack installed. But then you have like the things on top, right? Like for instance, we have Horizon to give you a ClickUps kind of thing where users can just like click on things and say like, yeah, I want 3 servers and whatnot. You have one service, I don't remember the name for DNS, which is similar to AWS's Route 53. So you can like name all your stuff with your own names and the DNS will resolve them to the right places. So yeah, there's a whole ecosystem of things that live in there, but these are the 6 core services. So next slide. Yeah, so this is just to reiterate what I just said. With Nova, you get compute. With Cinder, you get block storage. Neutron is networking. Nova instances are created from images, so that's why you need Glance to store the images. Swift is object storage, and Keystone is the identity service. So just reiterating on what I just said. And this is Oscar or Laza again.
Okay, so we already explained a little bit on which are the different use cases or who are like the customers that would like to have this kind of configurations, right? I'm just going to elaborate a little bit more on this topic. So the first one is public clouds. Actually, there are some vendors, some that are implementing in their sites this OpenStack and allowing customers to pay for that service, right? It has the advantage that it is well documented. You don't need to, in the case that you want to move to another vendor later, it is not working for you, or this site it's closing for whatever reason, you have the flexibility to move to some other place, right? The other one is hosted private cloud, which is, let's say that you are a really big company and you want to have all this flexibility that cloud allows you to do, right? All these, remove all this maintenance layer and all these people involved to make some stuff work. So you can, in your site, install the components that you may need for those use cases that you have, and reuse all that infrastructure that you already invested on. So it's really, it's having the cloud advantages, but inside. For example, I know that some banks, for example, they don't feel really comfortable with cloud, right? So they want to have it in-house. They feel better that way. They can handle and tweak all the security aspects. There are some more ones that it's remotely managed private cloud. You provide all the infrastructure, but someone else will take care of any issue, all the DevOps operations or any issue that will come on the cloud. You can hire a team, an outside team that will take care of that for you. So you only provide the bare metal, and someone else will take care of the software layer. And of course, there are some other infra solutions, because this is something that is used by a lot of companies. There are consulting services. For example, I saw on the page that Dell provides this kind of services. So that is like the general idea. In real life, I know that some companies, for example, they have like a mix and match situation where they need some specific modules, but let's say that you want to have your new cloud service, but you want to have the object storage, for example, but everything related to the virtualization, you want to handle but yourself, because you have another virtualization technology that you want to use. So in some cases, companies tend to have a mix and match solution, so they can jump quickly onto cloud, but without doing all that additional development work. Actually, it's investigation and development. So this is pretty nice. Can you go to the next thing? Thank you. So this one is for you, Ricardo?
I think so. Yeah. Sorry, I forgot exactly what slides I did. Yeah. So this is, again, just reiterating a little bit what I just saying. It allows your infra to be converted into a cloud, right? So you have a bunch of servers lying around, and instead of having someone like spin virtual machines in each one of them, and then containers in each one of those little virtual machines, and networking them together, you get that all with like very like with APIs, right? So it's easier to use and less error prone, and allows you for autonomy, right? Like you don't depend on anyone. And also, OpenStack exposes a well-defined API that helps you avoid vendor lock-in, right? So let's say you have your own cloud on-prem, right? And you're working on it, but you decide that, hey, you know what? There's this company that offers that can give me this kind of like private cloud just for myself. They manage it. They have their own infra. I can just use the exact same scripts, the exact same software, the exact same everything that I use, because all OpenStack clouds use the same API, which is not the same, which is not something we can say between, like, let's say AWS and GCP, right? Like they have different APIs. So if you have some script or some whatever, some code that helps you deploy resources in AWS, that is most likely not going to work in GCP. So vendor lock-in is a real thing with clouds, and this helps you move away a little bit from that. So kind of like open sourcey. That's one of the benefits from that. So yeah, next one.
Yeah, actually, in the first paper that we read, that was one of the challenges for cloud, right? And OpenStack is a solution for that problem. Yeah, continue, Ricardo.
Mm-hmm. Yeah, so just like to mention one of the services that we mentioned earlier, Nova is the kind of the open source project. Again, these are all little projects and they all work together, right? So Nova is a compute service of OpenStack. It's like EC2. And basically it needs Keystone for identity and authentication. So if I want to like create a resource, like I want to tell my OpenStack cloud, hey, please create me a couple virtual machines. It's like, sure, give me your access token. And if you don't have it, go away. I'm not gonna do that for you. So Keystone is the one that does that. So Nova kind of requires user authentication and authorization. It pulls the images from Glance, which is like some other OpenStack service that is mandatory, and Neutron for networking. And the important part is that it exposes a REST API to manage these compute instances and can also work through Horizon dashboard. So I don't know if it's precisely the next slide or sometime later, but I will show some of the API calls.
Okay, thank you. Just to give you a little bit of I know that this looks a little bit complex. I just want to explain a few things from here. There are 3 ways that the different modules interact. The first one is using HTTP, which is these are APIs that we already explained. For example, in this case, this one is Nova. Nova using HTTP will interact with all the other modules, Keystone, Neutron, Glance, placement, all that kind of stuff. So everything will happen in an HTTP communication, using an HTTP communication protocol. They can also share a device. There is another way where they can interact. And the other one is using RCP, which is something that we learned also in the first distributed systems, right? This is a way to have a cluster. You can configure this in a cluster and you can exchange messages across all the parts. Another advantage that we have here is we have a hypervisor layer. Can you go to the next layer, please? So in most of the modules, it has some flexibility. So you can use any technology that fits more for you. For example, if you do some investigations, you will see that KVM is the virtualization technology that is most used in OpenStack, but it allows you to implement any of the other ones. So it allows you to have that kind of flexibility. For example, Keystone module, you can use some other, you can implement it in some other ways. Right now, I only remember SQL, which is not the most secure one, but it allows you like 5 different ways to securely save all these users and policies and your credentials, right? In the case of Sun, which is the container one, you could use the Docker, which is the most popular, but also you have the one that is for, well, there are like other 5 containers technology that you can use for your use case, or you can mix them if you want to. So, okay, let's go to the next slide. This is something that we explain in general level. It's just a reminder on how it works. You can interact with OpenStack in 3 ways. One is the UI, which is Horizon. That is one, it's the easiest one to use from user perspective, but it's pretty limited, right? The other one is using the CLI. It is written in Python. There is OpenStack CLI, which allows you to interact with all the modules. And there are also CLIs specific per module if you want to go some other stuff more specific. At the end, both of them are just translating your command into an HTTP call. So you can also skip those layers and do the HTTP call directly into your component. So based on this, now Ricardo will explain how we can do these HTTP calls so you can know how we expose this service with these resources. And it will be easier for you folks that are more technical, how you can map it, how you will implement OpenStack if you have to, right? So Ricardo, can you continue?
Yeah, so I did not add this in the slides, but if someone cares, you can go to this thing, OpenStack, the API reference for Nova in particular. And you can see like Swagger style documentation for get, post, etc. So yeah, so for instance, to create resources with RESTful endpoints, like the REST kind of paper says that you should use post. So yeah, if you want to create a server, like a virtual machine or something, you hit the server's endpoint, like whatever's your host / servers, and you can create a virtual server. And the API actual payload is in the next slide. So yeah, so this is just your typical RESTful JSON kind of payload. So for instance, there's not much interesting going on here. It's just saying like, this is the name of the server. Please use this image, which is a reference to to some image in the Glance server. Flavor is akin to like, you know how in AWS you have like T1 dot whatever, medium, small, like different machine sizes, and they have funky names. And here you can define your own flavors, which tell you like what are the characteristics. So you can specify like the amount of memory, the amount of CPU, and you can, in here you specify the flavor, availability zones, this personality. I actually don't know what it is, but security groups are similar to security groups in AWS. Like they're essentially like networking rules that allow you that allow you to specify who can connect and who can't. So yeah, like there's a lot of data in here. Not all of it is super important, but yeah, the point is that with this very simple API call, which you can like create a little web service that you click a button and sends this post payload to this endpoint, or you can just like have this data lying around in little JSON files, and then you can curl your way into creating stuff. But the point is, you create stuff with an API. You don't need a person to do it for you. So next slide, just another example. Again, with RESTful endpoints, once you have a resource, you typically access it through like /resources, whatever, like the plurals, in this case /servers /server ID, and then probably some action, right? So for instance, in here, you can do I believe it's a put or a post, I don't remember. So you hit this endpoint like server ID action with different payloads, and for instance, you can create security groups or change the password of the admin just like this, like the admin password, just put it to this. And again, it's not like just about anyone can do this. You have to authenticate with an access token that Keystone gives to you. So it's probably something like authorization bearer or something along those lines. But again, just to drive the point home, this is an API. You don't have to ask someone to do this for you. You can just manage all your infra from the comfort of your own chair, just making API calls.
Thanks, Ricardo.
Sure.
Now we have here an example of AWS versus OpenStack, and here it's one for networking. In Amazon, they have this ELB, and OpenStack we have Neutron, and with Neutron plus an Open vSwitch, you can do like a load balancing as a service. And according to the documentation, it has 3 supported modes: round robin, source IP, and list connections. Or you can also use one of their projects, which is called Octavia, and this will do the load balancing for you. Another difference between AWS and OpenStack is VPC, which is Virtual Private Cloud in Amazon, and in OpenStack you have it also through Neutron. And also Neutron, since it's almost everything that's network as a service, it provides you like VPN, SDN, security groups, as Ricardo told, and firewall as a service. Here we have just like a general architecture. This image was taken from the OpenStack web pages, documentation, and here you have like all your compute nodes and your network node, and how you can connect them between them, and how you can expose your compute nodes to the internet. Or if you don't want to expose your compute nodes, you can just close those interfaces and put it through the network node, let's say. So you can always redirect all the network through that. Talking more about Neutron, one of the things that it actually gives you is through in layer 2, which is like Ethernet and switching. It supports like Linux Bridge and OVS, which is like open vSwitch. And with this and the things about layer 3, which is the DHCP and routing, you can have all these nice things from network to secure your cloud, and also to make it work as expected, right? One of these 3 services about routing is like VPN as a service, load balancing as a service, and firewall as a service. Here we have just one way you can put this Neutron to work. Like you have your compute nodes, your virtual machines, all through the network to the Neutron router, which will be on another node, and then you have like your output through the internet, right? Or through another compute nodes. All this is done through the Neutron application or service. Now, another service is Octavia, which is the load balancing as a service. As Ricardo said, it depends on other services, the key services that it's needed to have the OpenStack. The Glance, Keystone, Neutron, and Nova. And here we have like the diagram. The Amphora driver here actually is the one that is doing the load balancing, but they put it like this way, so you can put anything instead of the Amphora. You can move it out and put your own driver, so to prevent the vendor lock-in, right? Here you have like the agent and the Octavia workers, which will be doing all the network balancing. Also with the database, right? And last but not least.
Yeah, I mean, well, just to conclude with this, we would like to share with you some famous companies that have successful cases with OpenStack. The first thing that I want to show you here is it's not an industry-specific solution. Telecommunications, airlines, video games, banks, science investigators, retailers, they use OpenStack. So it's a solution that that gives them enough flexibility so they can have the cloud solution for them. Just to give you just a quick summary on how some of them are using OpenStack. For example, in the case of Blizzard, they use it for this game called Overwatch. So when people connect to start a game and there is not enough servers to do all this matchmaking, they can raise new instances, and they can on demand create or delete services, so they can save money on all this online layer for the game, right? Santander, they use it for big data. T-Mobile, I believe that they have some edge servers, and when they want to replicate that information into the core server, they use on OpenStack. Walmart, they have a lot of automatizations based on OpenStack. They have some product called Galaxy that it's automatically handling all these resources that OpenStack is exposing, and it is able to provide some tweaks to their cloud, so it can be as profitable as possible, right? I mean, just to give some examples, if you go to OpenStack page, you can see all these use cases, and there are 30-minute conferences where they explain how they implemented this and how it is working for them. In case that you want to learn a little bit more on this, it's a good resource. It is, you need to go. Yeah, there are a lot of videos in case that you want to take a look. It's really interesting. So, I mean, guys, do you want to add something to close on this?
I think that would be all. The only thing that I will add is just that this OpenStack has, it's harder to maintain than just to click for AWS or, I don't know, Azure or OCI or any cloud service, because you need to create it from all the APIs, right? There's a lot of documentation. It's really well documented, but it's too much. So you really need to know what you're doing to start using this OpenStack technology and projects. But it's really, really good, right? It's free, so it's something to look for.
Yeah, it's an option, and options are always good. So thank you, everyone.
Questions?
Regarding the last slide, it was showing current users of OpenStack, but my question is, they are using OpenStack for everything? I mean, Santander has everything in OpenStack, or maybe they are using a mix of maybe Azure.
Usually,
OpenStack.
all these big business are not putting all the eggs in the same basket. So, for example, Santander is using it only for some specific operations on big data. It's to retrieve information about all the transactions that are happening in their end, but it's just for big data. In the case of Blizzard, they use it for just one game. Probably there are a few more, but the one that they are exposing it's Overwatch, right? So in most of the cases, you spread different layers of your operational tasks in different cloud services, right? It's not common that you have everything with the same one. For example, I saw that Verizon is using OpenStack, but also I know that they are with some other cloud providers. So no, I didn't found a single case where it's the only solution for them. It could be possible, but I think that in this size, and the size of these companies, it's not common. You won't find that kind of situations.
Thank you, Oscar.
I have a question. I don't remember if you say it. How they make money?
Yeah, in this case, because it is OpenStack, it is maintained by community, but there are some companies that are building these products over OpenStack, and that thing it's not really, it's not common, right? There are some other products that are using an open source product, they tweak it and then they sell it. So in this case, it's open for the community. There are some companies that are using it for provide trainings. They have trainings. I think that they also accept, you can donate to them. But it's usually, most of these open source products are by and for the community. And yeah, and that is what I will
Okay,
say.
thank you.
Thank you, Pedro. Any other question?
I mean, I was just checking the website as you were explaining. So basically, you can sponsor the foundation. You can join the foundation as a membership. You can learn more about it in the join part. So as they said, it's basically by community for community. And that's great. Any other question?
So do you know when you were doing research of like, to say something, I don't know, for the case of T-Mobile, like, okay, I will use OpenStack, but I will use like my own version of OpenStack. Like I don't know, I was thinking like forking the whole repo and just setting or making it their own. Did you like find anything related to that?
I didn't find that specific use case, but what I saw is that it's common that you are working on OpenStack and eventually some patch killed one of the services, right? So you need to patch it. It's the same thing that you and I were discussing about Home Assistant, right? It tends to break, so you need to tweak it. So I think that it's possible that every company has a fork of the project and they tweak it and they update from time to time, but it's not, you don't want to play with production, right? So it's not a common operation, all this patching. So yeah, I think that at the end they will have a fork, but I didn't find an explicit mention on that.
Okay, thanks.
I just shared the GitHub link though. So I mean, it is just an open source project. Like in this OpenStack repo, like there's the sub repos for Nova, for Keystone, Neutron, etc. So I mean, if you go to, for instance, Nova, you can see that there's already like 2.5K forks. So I guess that kind of answers the question. I mean, I don't know exactly if Blizzard has their own fork or if they're using like the stock version. But yeah, like everyone is able to fork it, create PRs, everything they want.
Okay, thank you guys for the presentation. It was quite interesting, at least for me. I learned quite a lot, honestly. I didn't know much about it. So I would say let's take 4 minutes break. We come back 8:15, and then we would have just one last presentation. So Fernanda, Alejandra, Brian, you can do it next one, okay? Next presentation. Okay. So we'll have one, we'll continue 8:15.
To present, okay. We're going to present the Kubernetes auto-scaling. The team is Manuel, Rodrigo, and me, Javier. Well, we are going to explain a little bit of background about Kubernetes, a brief introduction to these topics. We're going to talk about control planes, workers, advantages, namespaces, pods, nodes, schedulers, YAMLs, deployments, and also the auto scalers, horizontal, vertical, and at the end of the presentation, we are going to give you a brief demo of how to use Kubernetes with horizontal autoscaler. So I hope you enjoy it. Well, Kubernetes has some advantages. It is an orchestrator. We can define some advantages like Kubernetes can work on automated containerized environments, such as if you have a container image, you can create a pod and deploy your application. So it's not working with it's working with containerd. Well, at least me on my job, I use containerd to deploy the containers that I have with Kubernetes. Another advantage that can be matched with other is the scaling up and down and the cost efficiencies and savings. Why? Because Kubernetes has the capability to scale up or down depending on the necessities that you have, like company or your application. In this case, imagine that, I don't know, you have a streaming app that by certain moment of time, your application needs to be expand. It's going to expand the users or the services. So Kubernetes can do this, adding more pods or somehow with other configurations or contributions. So this can ensure the performance without being wasteful, because it can adapt to multiple environments. Another advantage is the strong open source communities. Well, Kubernetes is open source since 2014, was donated by Google to the CNCF. So right now it has like 100,000 commits, over 3,000 contributors. Also the ability to run anywhere. I noticed that you can run on different OS. I mean Windows, I mean Linux. I currently use Kubernetes on Linux, and it's their performance is it's really nice. Also, well, it can be used on multi-cloud possibilities. I said AWS, GCP, Azure, and well, for the demo that we are going to show you at the end of the presentation, I think we're using GCP with GKE, Google Kubernetes Engine. So, yep. Well, the control plane. This information is like newer for me, because I didn't notice this since a couple of days ago. The control plane is more called as the master nodes, you know? The master nodes where it has these three different capabilities of exposing the API. Then it is the master node or the control plane is acting as the scheduler, because the control plane shares the tasks to the other worker nodes to divide the workloads that you want to run, or even if you want to run workloads in parallel, you can do it. And the persistent store, persistent store is like checking the state of the application, the state of the cluster, to ensure everything is working well. So then we have the Kubernetes nodes. The Kubernetes nodes are the nodes that are part of the cluster that follow the control plane in this case, and they have three different characteristics. That they contain the kubelet service, the container runtime, and the network proxy. The kubelet service basically is watching the API server for new work and tasks. The container runtime is I don't know if you guys or I'm not, I don't know if I'm incorrect, but there's a tool called the K9, and here you can visualize all this container runtime, because you need to know this type of runtime to check if you need to stop a container image. You need to check if the container image is terminating. You need to check all that stuff. So it's really important. And obviously the network proxy, because if node doesn't have the network proxy and it's not joined to the cluster, well, it doesn't have sense. Then we have another topic, the namespaces here in Kubernetes. The namespaces are basically the way that you are labeling those type of nodes in the cluster to try to divide that cluster in another mini cluster or subset of systems that can execute a task. And well, the namespaces have some objects, as you can see here, such as pods, services, and deployments. This is an example of a YAML file, for example, that it has the deployment part, the pod type, and the apps and dependencies. In this case, is defining the container image and defining the port, container port, I think. Then this is another topic, really interesting topic. Basically, the pods are the well, as it says, the atomic unit of a scheduling Kubernetes task or app. When you are deploying a container, you need a pod. Basically, if you don't have a pod, you can run anything. You can, in this case, we have 3 examples that are in the Kubernetes book. Basically, for me, those are the more interesting that I want to share with you guys, because in my job, I noticed that yes, I can run 2 different containers inside of a pod, and they will share the same proxy. What? Sorry, the IP. The IP. They are going to share the same IP. If you apply, I don't know, hostname minus I to inside of each container, you will get the same IP. The thing is that it's really interesting because we didn't know how to run HA proxy or different type of NGINX stuff to try to communicate both containers inside of a pod. So we noticed and that there are so many ways. Maybe if you communicate by the port, but in this case, the most easiest way to do that is communicating via localhost. So you can communicate the main container to supporting containers, or your init container to the other containers that you have on the defined on the YAML file. This is this image represents one of the advantages of Kubernetes. You can scale up by this way, adding some pods, and it's not necessary adding a lot of containers in the same pod. So,
but also you can communicate by service name, right?
I didn't know that. It will be interesting to check that one.
Yeah, you can do it, I think so.
Then there is the scheduler, one of the activities of the control plane. Basically, the control plane watches the API server to try to some way schedule the tasks to the other nodes or workers inside of the cluster. Basically, it's more complex than that because there is like a ranking of. Can you hear me?
Yeah.
Okay. Yeah, this is more complex than that because it's like some type of ranking that basically the scheduler is also checking for the healthy of the nodes. Maybe if you have a node in terminating, it will stop sending tasks because it's going to omit that part. Well, the scheduler, and well, if I don't know, basically is that. It's like a ranking. It's taking the ranking of the nodes based on the workloads and the healthy of the nodes, and then try to schedule some tasks to all the cluster systems with the labeling, with the label, with the same namespace that they have. Then we have a YAML right here. Well, the YAML, I don't know if you guys know about what is the YAML, but pretty much as a JSON, but a little bit more efficient.
Yet another Mark language.
Yeah, basically is that.
That's the kernel of YAML.
So yeah, you can define different objects. Sorry. Oh man. Yeah, you can define different your deployment. Here you have the API version that you are using of Kubernetes. You're defining the class of deployment. You're using well, the metadata using as name and Nginx deployment. Then well, you are indicating to the controller how many times, well, to execute in two pods, and well, the spec of the containers, checking the name. Even if you have, I don't know, Elasticstack or something like that that is streaming data, you can search for this type of fields more easy, searching by Kubernetes container name or something like that, and the container image on the port that we already mentioned. So it's quite simple. The deployments, well, you have a Kubernetes object that creates a Kubernetes pod, and then you will have these features, basically the self-healing, scaling, zero downtime rollouts, and version rollbacks. It's not that difficult. Oh man.
Yep. So that's on me. Now, thanks, Alex, for that quick introduction into Kubernetes. As you can see, there are many moving parts, but well, at least we have mostly explained the most important ones and the ones that you need to understand before actually jumping into scaling. So basically, what is autoscaling, just as a quick recap, is to dynamically and automatically adjust the amount of computational resources. And well, ideally, it should be based on activity and demand. And Kubernetes offers 3 different scaling dimensions, either vertical, horizontal, or at a cluster level. So we will see the 3 of them in this case. So first, we need to understand 5 important, well, we could say 4, and the 5th one is just like a thing that we should know. So for the first one, I mean, we need first to understand how we assign resources into each one of the pods. And we have first or mostly 2 types of resources. That is the CPU and the memory, or the RAM, basically. CPU is considered at a pod level as a compressible resource. What this means is that it is easily throttled without severe consequences. So if you start throttling the CPU, the only thing that will happen is that you start getting slower, but the process won't be ending. I mean, it will just take more time. And in our case, it is measured in Kubernetes CPUs, or TCUs, as you can see. And we can use units like 100 millits, or 0.1. And we have the other important resource that we must consider in our pods, that is RAM. And it is considered as incompressible. Why? Because if you don't have any more memory, then the process crashes and the container needs to be restarted. Why? Because in itself, Kubernetes doesn't know how each process is mapping the memory. So if you take memory from the process, you might end up taking something that was very important for it. How it is measured in bytes, and you can use 1 megabytes, maybe bytes, gigabytes, and the like. Okay, that is for the resources. Now we need to understand how each pod controls these resources. For that, we have requests and limits. Requests is basically the amount of the given resource that a container requires to function properly. And scheduling depends on this amount. I mean, you need to define how much you need so that the scheduler knows that it can sit you in a place where you have that amount that you need. And we have limits. The limits is the maximum amount that you should be consuming from a given resource. And if you start going over it, as we said, in the CPU, you start to be throttled, and in the RAM, you can end up with a container being killed. And one important thing is that you can play with requests and limits by having different values in them. You can get into some overcommitment so that you can have more memory in case that you have bursts or drainage of requests, and that gives you on average better resource usage, because I mean you can have like lower requests and more limits, and when you are not up to the limit, you can go on and just grow up to that given limit, of course. Can you go to the next one, Alex? Okay, we'll start with the first one. And the first one is the vertical path autoscaler. What is scaling? This one, scaling vertically, is adding more memory or CPU resources. And what does the vertical path autoscaler does? It just better matches the actual usage rather than the hard-coded predefined values. And it is composed of 3 components. We have the recommender, the updated, and the admission plugin. The recommender, as you can see in the first part, we have here a pod that is this cube, and it has some metrics. Let's say that you deploy this pod and you say, hey, this one will be consuming 100 millis of CPU, but the pod is actually consuming 200 millis. So this one, the recommender, is always monitoring, and what it does is that it recommends better CPUs and memory values. Then the updater kicks in, and what does it do? It just deletes the pod, deletes this pod with incorrect resources, so that new pods with the recreated or recommended values can be created. And then the admission plugin comes in. As you can see, this new pod is bigger. It has a bigger CPU, and so its set value for requests. Yeah, and well, there are multiple modes. We have the recreate. That means that the values assigned on the pods it is made at creation and can be dynamically updated based on recommendations. We have the auto mode, which is not implemented yet and will eventually do an in place update. This means that the updater won't be killing the pod, but instead will do the vertical upscaling at that very same pod. And there are other 2 modes. There is the initial one, that the values are assigned only at pod creation, and you can just turn it off and just watch the recommendations. That is something that we usually do when we are first seeing if the vertical pod autoscaler is working okay. Can you go to the next one? Yeah. Here we have an example of a YAML. As Alex said, everything in Kubernetes is managed with this type of representation. In this case, we have the update policy set to auto. Yeah, that part of the presentation is wrong. Well, it is auto there. It is not set to off. And this means that it allows automatic adjustments in certain range. And which range? As you can see, the min allowed is 100 mil, and the max allowed for CPU is 1. And for memory, we have from 500 megabytes to from 50 megabytes to 500 megabytes. So the vertical pod autoscaler can work in that range. Then we have the horizontal one. The horizontal one is, this one is for scaling. The other one was for scaling up and down, and this is for scaling out and in. This means adding more pods to your already being deployed pods. And well, as you can see there, it automatically scales the number of replicas in a deployment or a stateful set, depending currently only on CPU utilization. Eventually, it will also work on RAM, but right now it only focuses on CPU. And how does it work? You can consider it basically a continuous closed loop controller. First, we have here the horizontal pod autoscaler. Well, we can start maybe the other way around. If you go after the control output and see the feedback, you can see that the control output is basically what it is happening at the cluster currently. And you get a metrics average from all the pods. So if you have like 10 pods, you would get like an average of CPU usage from those 10 pods. This measurement goes into the controller, that is the HPA. that basically after seeing what is the metric average, it compares it with its target average. And if it determines if it needs to add or just remove pods to get closer to this target average. And then it indicates to the actuator, which is the scheduler, to add or remove replicas, and then the process just puts it in. And then after some time, we again capture the metrics from the mpods, and this continues running all day. There is, can you go back just a little bit? There is an important mechanism here that is the stabilization windows. And this one prevents these scale downs to be executing so quickly because we don't want replica flapping. That means that these values keep fluctuating in a very small amount of time, and therefore the cluster just keep growing, scaling out and in all the time. And that's why we have a stabilization window, which can be customized. Then we can see its representation. There, for example, again, is a YAML, and I think Manuel can better explain this one.
Yeah, sure. Can you hear me? Yeah.
Yep.
Okay. Well, we want to show like this example because it's the same that we are going to use in the demo. So, well, it's very simple. We want to use an horizontal scale. So, well, we need to define it. And after that, well, we are going to use an external metric. In this case, pop and sub. It's something like Kafka. And we are going to define the number of replicas that we want to use. In this case, the minimum is 1 and the maximum is 5. As I already said, we want to use an external metric. In this case, we want to use the pop and sub API, the subscription part, using the number of undelivered messages. And we need to define which topic we are going to read. Well, in this case, the subscription. We are going to read the echo read. In the demo, I'm going to show you how we create the topic and the subscription. But well, we are going to read it. And the target is the value that we need to reach in order to increase or decrease our application. So in this case, we need to reach 2 unknown messages on average in the pop and sub topic. So that's it, I think so.
Yeah, thanks, man. And finally, we have the last important autoscaler for the last dimension. And in this case, is the cluster autoscaler. That it basically scales the cluster to accommodate changes in demand for compute resources, again, but in this case, by adding more nodes to run more pods. It is important that this cluster autoscaler is very related, or must be in a, I mean, yeah, it is very related to the cloud provider or wherever you are setting up this Kubernetes cluster, because it needs to have a way to get more nodes or servers from the provider into the cluster. And therefore, we have vendor-specific plugins for example, AWS, Azure, and GCP. And how does it work? As you can see right here, first in the first part, in the drawing that is right here. Maybe I can share the mouse, just a second. Annotate. You see my mouse there also? Do you see 2 mouses? 2 mice? No,
just
right?
one.
Yeah.
Okay. Or maybe I can draw. Can you see here? Okay, there's that. So in this first part, as you can see, we have here basically a 1 node cluster. There's a node, and here we have 3 different pods. So basically, we have right here the horizontal pod autoscaler, and it says that, I mean, the cluster this is the horizontal pod autoscaler, the one that is up here. This is the horizontal pod autoscaler. So that one says that we need to have an average CPU, that currently we have an average CPU usage of 1, but we want to get into a target CPU usage of 0.5. So it orders for us to add more replicas. And the scheduler says, okay, I will try to add them. And then he gets those into a queue, but they all remain as pending because the cluster has no vacancy. There are no other places in which we can add more replicas of this pod. So what happens? As you can see on the right, this wheel, which is Kubernetes, through its cluster autoscaler, asks the cloud provider for more servers. And after it provides it back to it, we have this scenario that is right at the bottom, in which we get a 2-node cluster, in which the first node is already there, but for the second node, we set up we start adding, the scheduler now has vacancy to start adding those pods, and then the problem is solved. But it also works the other way around. Whenever it finds out that a node has pods that are not actually consuming CPU or RAM, it can just remove pods from the cluster. Can you go to the next one, Alex? And yeah. So how do you enable? There's no YAML here, guys. Sorry, it's just some commands. And in this case, there's an example here from gcloud, in which when creating your cluster, you can set the initial size of the cluster, then enable autoscaling, and then set the minimum amount of nodes, and also the maximum amount of nodes. And that would be enough for the cluster autoscaler to be set. There is also an API for you to set like the metrics of what you want to be considered as metric other than the parameters passed by the horizontal pod autoscaler.
Okay. Can you pause it? Okay, so well, as I already say, we are going to use different resources in this demo. We want to create a Kubernetes cluster. We want to create an application. And with that application, we are going to read different messages into pop-and-sop topic using a subscription. And we want to show you guys how can we create different replicas when we reach some kind of target or rule into our autoscale metric. So, well, you can play it. So, well, first of all, we need to activate the Kubernetes API. And well, after that, the next step is we need to set up the Cloud Shell. In this case, we are going to define the zone, the default zone into the SDK. And also we want to define our project ID. In this case, we use cloud computing. So that we define the zone and the project ID. And now here we create the cluster. This could take like 5 minutes. But well, after that, we need to create a new resource model. With the resource model, we create a way in order to communicate between the stack driver in order to use the external metrics. So in this case, we already created, and we want to use the pop-and-sop metrics. And now we want to download the Git repository in order to obtain the code that we want to use in our application. This is the code. So it's pretty simple. We are going to read the topic, and we create a little bottleneck using the sleep and the 3 seconds in order to reach the target of 2 read messages average. And now we need to create the pop-and-sop resources. First of all, we need to create the topic, in this case, echo. And we are going to see it in a moment. Okay, so there is our topic. And after that, we need to create the subscription. We name it as Echo Read. And there is it. Oh, okay, so now we have our topic, our subscription in order to read the topic. And now we need to create a service account. We are going to use a service account in order to create this kind of interaction between our Kubernetes cluster with the external resources, in this case, the PubSub. So we create a service account, and we are going to give it the privileges of PubSub subscriber. So we are going to use the PubSub subscriber role in order to read the content of the topic using the subscription. And after that, we need to create a key JSON. And we are going to send the key JSON to our Kubernetes cluster as a secret. So we can see the content of the secret. And that's the service account that we created some moments ago. So yeah, I know, but I only have 7 minutes. So right now we send the secret or our key JSON to the cluster. We already have our secret. So now we can create our application with the code that I already showed you guys. So, well, one moment, let me. Okay, so we are going to use the Python code that I showed you. And with that, we create our application into the cluster. Probably in what moment I'm going to, no, oh, okay. So the PubSub application is already up, and there is it. At the beginning, we are going to have one replica, but we want to create the rule in order to create more replicas if if we reach the limit of our metric. So right now we create the horizontal rule, and we are going to watch it in a few moments. Okay, so we create the rule here, and we are going to have, like I already showed you in the other slides, we are going to have 1 to 5 replicas, and we want to reach the 2 unread messages in average in order to create more replicas. And also we can use cloud monitoring in order to understand this in a better way using the graphics related with the metrics that we use. And well, in this moment we don't have any data. The one that we see is my first test. So right now we don't have any message. So that's why we need to create this kind of new messages. We are going to send 2000 into the topic, and we need to wait until the messages and the little bottleneck that we create arrive to the topic, and with that we are going to create the new replicas when we reach the 2 unread messages into the PubSub topic. So for now we only have 1 replica, so we need to wait a little bit. And after some time we reach it. Right now we have, like, I don't know, 50 unread messages probably. And at some moment we are going to see the new replicas. So well, that was really fast, but right now we have 4 new replicas, and all of them with these logs are consuming the subscription. So yeah, as you can see in the console, and there is a message of new size of 4 and new size of 5. So okay, right now we have the maximum amount of replicas, and when the messages are already consumed, all of them, we are going to decrease the size of our cluster. So right now we have only 1 replica, and that's it. So yeah, now the last size is new size of 1. So yeah, thank you.
So I don't know if you guys have questions.
And thank you guys for great presentation. Any question from student?
Like there's like I'm not an expert on Kubernetes, but for example, at least in my company we use Kubernetes and Argo CD, for example. And I remember that Argo CD it's also managing like for example, some of the deployments, some of the auto scaling and things like that. I don't know how Kubernetes works on the delegation, and also how you say if what happens if one pod dies, like does Kubernetes manages like the pod deletion and restarting a new one, or
Yeah, it's an orchestrator.
is a complete orchestrator?
Yeah, I mean, what it does mean is that the deployment part that we explained at the beginning, you really don't manage pods directly. You really, I mean, you really work with either deployments or stateful sets, and those deployments are in charge of also monitoring whenever a container is down. In this case, a pod, we can consider it as an equal to a container, and it brings a new one in if necessary. So the deployment is in charge of that part. And also it is in charge of whenever you update an image, also killing containers with the older image and bringing in new containers with the new image, and also guaranteeing like a very small downtime. So yeah, it also manages that part, and that's one of the main reasons we use it.
I think there is no downtime. You have the pod is created, and until the new pod is ready and has happened the libnet provenance and the readiness proof, then that pod, now the load balancer is going to take the traffic to that pod, and the other one is going to be deleted. But yeah, there are no downtime.
Yeah, exactly like that. And you can even go on and specify, like for the deployments, you can say how many you want to be up with the new version before one goes down. And for example, do blue-green deployments too. I mean, it is great in that sense.
Yeah, sorry, but that's what I do most of the time. So that's the reason that I know. But yeah, that was a great presentation, actually.
Any other questions, comments? No, everyone wants to finish this. Okay, thank you all of you for presentation. Great topics. Yeah, that's it. I mean, let's I see you next week. Okay. Have a great night.
Yeah, we need to do something about this 15th, Matis. Twice we have had this scenario already. The having class on the 15th, on the September the 15th. Last year we also had that class and that same.
Really?
Yeah.
Yeah, everyone is ready for the greeter, right?
Yeah. Everyone
is just ready for closing the computer and go.
Just
go into the
yeah.
Okay,
I'm already there. I mean, like my pozole plate is like just after my computer. I mean, I just need to close it down and start eating.
Okay, great. So yeah, have fun, everyone.
Yeah, you too, Maddie.
Maddie,
Bye.
I have a question. When we are going to do the presentation,
with the second group in
October 18th.
okay.
Yeah.
Okay, sounds good. Thank you.
Okay.
Great.
Bye, guys.
Have fun, everyone.
You too. Bye.
You too.
Bye.
Thanks, you too.
Bye.
Bye.
Bye.